Welcome. This is exercise 3.1, GCE A-Level, Pure Maths, Year 2. We've got 3 questions to answer. Question 1. Find the sum of the first 10 multiples of 7. B. Show that the sum of the first n multiples of 7 is 7n over 2 brackets n plus 1. So the first term is 7. If you add 7 to 7, you get 14. And that becomes the second multiple of 7. If you add yet another 7 to 14, you can get 21. And that is the third multiple of 7. So this forms the first 3 terms of the sequence. That means the common difference is 7. But the sum is given by this formula right here. All we do now is substitution. We know n to be 10, a to be 7, and d to be 7. If we do the substitution, we get this. If you simplify, you're going to get 5 brackets 14 plus 7 times 9, and a further simplification will give you 5 times 77, and evaluating gives 385. So that's for A. For B, we know the first term is 7, the common difference is 7, and the sum is given by this formula right here. On this occasion, we don't have the value of n, so we substitute A and D to get the expression required. So we're going to get that. Simplify to get n over 2, brackets 14 plus 7n minus 7. But 14 minus 7 is 7. So you get that. But we also know that 7n plus 7 can be factorized to get 7 brackets n plus 1. So that will replace what is in the brackets right here. And that will give us 7n over 2 brackets n plus 1, which is what is required in the question. So that's question 1. Question 2. An arithmetic sequence has first term A and common difference D. Fifth term is minus 19 and the 11th term is minus 43. A. Find the value of A and the value of D. B. The nth term is minus 79. Find the value of n. So the nth term is given by A plus n minus 1 D. So the fifth term will be A plus 4D because 5, which is the n, minus 1 is 4. But we are told that the fifth term is minus 19. So we can equate this to minus 19 together. And then we can label it as equation 1. We do the same thing for the 11th term. So the 11th term is given by A plus 10D because 10 is the same as 11 minus 1. We know that the 11th term is minus 43. So we equate this expression to minus 43. And then we can label it as equation 2. We can now solve equation 1 and 2 simultaneously. And I'm going to subtract equation 1 from equation 2. So if I do that, I'm going to get A minus A is nothing, 10D minus 4D is 6D, and then minus 43 minus 19 is minus 24. I then solve for D by dividing each side of the equation by 6 to get this, evaluate to get minus 4, and so D is equal to minus 4. To find the value of A, I will substitute the value of D, which is minus 4, into the first equation. So I'll get A minus 4 times 4 is equal to minus 19. Then rearranging will give A is equal to minus 19 plus 16. And solving will give A is equal to minus 3. So that's for question 2A. For 2B, we'll use the nth term formula because we are told that the nth term is minus 79. Now that we know the values of A and D, we can go and substitute these values into this nth term formula to get the following. So we know that A is minus 3 and D is minus 4. So we do our substitution as follows. Minus 3 minus 4 brackets n minus 1 is equal to minus 79. Then we expand to get minus 3 minus 4n plus 4 is equal to minus 79. Simplifying the left-hand side gives 1 minus 4n is equal to minus 79. And then rearranging gives 4n is equal to 79 plus 1. That means 4n is equal to 80. Solve for n, and n is 20. So the value for n is 20. Question 3. The first three terms of an arithmetic sequence is k, 3k plus 2, and k plus 7. Find the value of k, that's A. For B, find the value of the 60th term of the sequence. So first of all, we find the common difference. The common difference can be calculated by subtracting k from 3k plus 2, and that gives 2k plus 2. The common difference can also be calculated by subtracting 3k plus 2 from 4k plus 7, and that gives k plus 5. So 2k plus 2 is a common difference, k plus 5 is a common difference. So we can equate them. And if we equate them, we can solve for k. And when we solve for k, we're going to get k is equal to 3. For b, we now know that the first term, which is k, is 3. We can get the second term by substituting the value of k over here to get 3 times 3 plus 2, and that will evaluate to 11. We can do the same thing for the third term by substituting 3 into k to get 4 times 3 plus 7, and that gives 19. So now we form a sequence. That implies the common difference is 8, because 11 minus 3 is 8, and 19 minus 11 is 8. Now the nth term is a plus n minus 1 times d. So the 60th term will therefore be a, which is 3, plus common difference 8, bracket 60 minus 1. Evaluate it, and you're going to get 475. And that's the answer for B. And this is the end of this session. Thank you for watching, and I'll see you in the next video.